Okay, so today we are going to discuss the electrophilic addition reaction, the mechanism, the one which we did yesterday. We'll continue with that. But today we are focusing on the addition of HCl or HOH or HBr to an unsymmetrical alkene. And how we have to follow the mechanism for the unsymmetrical alkenes and how the major and minor products are formed, right? So today's focus is that we'll explore the reasons that why a major and why a minor product is formed in the Marconi-Curves addition of HX or HOH to an unsymmetrical alkene. For example, if I write this CH3, CH, double bond, CH2, plus, let's say we are having HBr. So once we react it, the other day we said that as you can see, it's an unsymmetrical alkene. So it's a propene, carbon number 1, 2, 3. Right? So when we add this, now we have the two products in this case. Right? So if hydrogen is added to the carbon number 1, I suppose, at this moment, so the bromine will go to carbon number 2. So it's a 2-bromo propane that is formed. Yes, if we attach it carbon number 1, so CH2 becomes CH3 here. You see, this was CH2, it becomes CH3. And Br goes to carbon number 2. So it's a 2-bromo. It's a 2-bromo propane. Similarly, we also said that there is a possibility that it goes other way around. Let me tell you. If the hydrogen goes to this carbon, number 2, right? Then Br is going to go to the carbon number 1. In that case, the product will be, look at this. The product will be CH3. This will become CH2. And this is CH2Br. So product will be 1-bromo propane. So what we were expecting, that they should be in equal amount because there is an equal possibility or equal chance, but it's not the case. Actually, they are not in equal amount. The product that I have made on the top, I've written on the top, is the major product. It is the one that is formed in the major amount, and the one that is underneath is in minor. Let's say, for the sake of argument, I'm saying this number se baat zara samajh aati hai. Let's say 90% is the one that is there and 10% is the one that is there, or even more than 90%. So this is much difference between them, right? And this is first time figured out the Marconi curve. So that's why we also call it Marconi curves addition. Now, what is the reason? Today we are going to see the reason, right? And I told you yesterday that you can remember it either way, or you can remember that when hydrogen goes to the one that is already having more number of hydrogens, the carbon, that'll be the major product. For example, look at this. If I say in the first one, the hydrogen is going to the carbon number 1, and we can see that the carbon number 1 is having 2 hydrogens. On the other hand, carbon number 2 is having 1 hydrogen. So we assume that when hydrogen goes to the carbon number 1, as the more number of hydrogens present on the carbon number 1 as compared to the carbon number 2, so we believe that is going to be the major product, right? But the reason is not this. Let's explore the reason. Reason is always there in the mechanism because we just know what is happening in the reaction. We don't know why it's all happening. That is in the mechanism. Okay, so give the heading mechanism, then we'll see. Okay, if I write the mechanism for this reaction, you know it's a electrophilic addition reaction, EAR. It's electrophilic addition. So, for example, electrophilic addition reaction. Here it is CH2. And it's going to react with HBr. HBr, this side is partial positive, this side is partial negative. So we learned this yesterday, that this electrophilic addition reaction takes place in how many steps? Two steps. In the first step, the first part added. In the second step, the second part of the molecule is added. Okay? But with the first part that is added, where the electron pair comes in, where the electron pair, which electron pair is going to use make a bond between hydrogen and the carbon? Yes, so we say the double bond between two carbons, carbon number 1 and 2, that electron pair is going to be used. So that's why I put an arrow here. So you understand, this arrow does not mean you can put it anywhere. This arrow means the word I said right now, that the electron pair, the double bond that is being shared between two carbon, that electron pair is going to use to attach hydrogen with this chain. Okay? So this arrow carries the meaning. This curly arrows in organic carries the meaning. And this is the meaning, that the double bond, right? Any bond up or down, doesn't make difference. So the double bond electron pair is going to be used to attach hydrogen with the carbon chain. Now the point is where the hydrogen is going to get attached. Here there is equal opportunity. For example, if it is attached with the carbon number 1, I assume, so it is going to be CH3CH single bond, and carbon number 1 will become CH3, right? And the other hydrogen, other carbon, which has lost electron. Why lost electron? Because carbon number 1 taken the electron pair. It's so electron and the carbon number 2's electron. That pair is now going to is used to attach the hydrogen. Na? So this gets positive charge. Let me show it like this so you can have a concept clear. This is CH2 and this is the hydrogen. Now this hydrogen, which is I have highlighted, this electron pair, the line which I have highlighted, this electron pair. Now, this electron pair has one electron from this carbon, but the other electron belongs to this carbon. And as it has lost carbon number 2, as it has lost electron, therefore it gets what charge? It gets a positive charge, right? And this is known as, when carbon gets a positive charge, this is known as carbocation. Okay? And this carbocation, if you look at this closely, this carbocation is if two carbon attached. I told you if two carbons attached with a carbocation, that carbocation is known as secondary. So precisely, it's a secondary carbocation because two alkyl group attached. Two alkyl group attached, na? There is a one alkyl group, this one, and there's another alkyl group, this one. So two alkyl group attached, so it's a secondary. But there is other possibility. What is that possibility? If the hydrogen goes to carbon number 2, and then it is going to be CH3CH and this CH2 positive. Okay? And this is again a carbocation, but this is what? Yes. Because this hydrogen, the electron pair is being offered. So this any carbon can use this electron pair, not one only. Carbon number 1 can use the electron pair, or carbon number 2 can use the electron. Here it is an equal opportunity. Okay? No major, no minor. Right? So they have equal opportunity. Let's say we have 100 molecules of propene, 50 are going to use the one carbon and 50 others, the other carbon. Okay? So this is primary carbocation. But here is the catch. We learned in the previous part that the primary carbocations are not stable. They are what? They are unstable. On the other hand, secondary carbocation, we said they stabilize or they stable. And I hope you learned that and you know the reason. Why are they stable? They have how many alkyl groups attached? Both of them pass their electrons towards them, which is known as positive inductive effect. That positive inductive effect will decrease the intensity of the charge. Or in other words, the charge spreads on the both alkyl groups, right? That gives the stability, right? So I can show it like this just for the sake of clarity. You are not supposed to show like this here. Okay, these are the two alkyl groups. They are going to pass their electrons toward this, known as positive inductive effect. That gives the stability. So here is the catch. Because the primary carbocation is unstable, so it's going to technically turn back into the reactant again, right? So in other words, the primary carbocations are very, very rare to turn into the next step. right? Or convert it into the next step. In the next step, this bond between H and Br breaks by heterolytic fission, and Br turns into what? A nucleophile. So in the next step, this nucleophile, this one, comes in and uses this electron pair to attach with the carbocation. अगर ये यहाँ पे आ जाता है, look at this. Here it is Br negative, right? So what is the product then? The product will be, the Br is going to attach with the center carbon. The product will be CH3, CH, Br, and then CH3. Okay? So as this carbocation was stable, so this product is going to be the major product. As this, the carbocation which is under this is in a very less amount, cannot survive a lot, but still few molecules may be able to make it. So those molecules, those who can survive, they can turn into the products. So in that case, the product will be, yes, CH3, CH2, CH2Br, but that'll be the minor product in a minor amount. Okay, this will be in the major amount. So now I hope you got it. Okay, why that one is major and this one is minor? Because the intermediate, the carbocation intermediate from which the major product is going to be formed is a secondary, so it gives the stability to the carbocation. That is the reason that product is in a more amount as compared to this one. Sorry. No, I told you दोनों पे attach होता है, but the more amount goes to carbon number 2 or less amount goes to carbon number 1. मैं फिर इस सारे को explain कर रहा हूँ, right? So please इसमें आपको one final जो लिखना होगा वो ये, I'll explain all it again. So मैंने क्या कहा कि when an unsymmetrical alkene is added with HBr, there are two products formed. One is major, one is minor. We explained it why there is major and minor, because we know that the electrophilic addition takes place in how many steps? 2 steps. In the first step, the carbocation intermediate that is formed. So there are two types of carbocation intermediates formed. One is primary and one is secondary. As the primary carbocation is unstable, so there are very, very less chances for this to exist and convert into the second step to a haloalkane. Therefore, kind of, I can say that this is actually gone here. So it can't go to the next step, right? Let's say 50, we have, for the sake of argument, I'm explaining, this has 100 molecules. The propene has how many molecules? 100, right? Numbers just make you understand things. So there are 100 molecules. Out of 100, 50 made secondary carbocation and 50 made primary. But the primary ones, out of 50, only one survived. 49 gone back into their original thing because they could not survive, right? So those 49 then take which route? Major one, right? So those 49 now again turn into this secondary carbocation. So what is the total number here now? 99. One odd still who are able to survive, so that can attract Br negative. So once it attracted Br negative, so obviously Br negative is going to come and make a dative bond with this using its lone pair. So that turned into the product. And how many product then formed here? 1. So what is the ratio? 99 to 1. So this is what that actually is not happening. I just put numbers to make you understand how this all phenomena goes. Right? Okay, now questions? Organic में बनने वाले, all the bonds are kind of dative. When the nucleophile comes in, has a lone pair of electrons, so they can readjust later, turn into a covalent bond. Initially, they are the dative ones. Okay, now I'm going to give you an example. So numbers I'm going to erase because they are just to understand what is happening in all this, right? So we can write one sentence that the secondary carbocations, please put it down. Secondary carbocation having two alkyl groups attached has more positive inductive effect and gives stability to carbocation. Therefore, the product formed from secondary carbocation is in major amount. More amount. Okay, now I'm going to put a question here. But your butanine reacts with steam. We have to write a reaction and mechanism and what are the major and what are the minor products. Okay, so we have to write all the detail. Butanine. Reaction and mechanism. Yes, reaction and mechanism. So first of all, okay, I can give you the structure: CH3, CH2, CH double bond, CH2. This is the butanine, bacho. So it's going to react with the steam. We know the reaction conditions are 350 degrees Celsius temperature, 60 to 70 atm pressure, and yes, H2SO4 is the catalyst, or H3PO4. Here you go. Okay, now first you have to write the two products which are formed, which is major and which is minor, you have to label, and then you have to write the mechanism. Here your time, we have 2 minutes. Yes.